So in this video, we will talk about the Euclid's division lemma method in C compiler. So let us just get started with the block without wasting time. First of all, I'm specifying the hash include studio.h statement and then hash include standard library.h and just initializing int gcd to be u and v, two variables int u and int v. We are just initializing the variables into the parentheses and then next printing the float absolute value to be float x. So let me just tell you what the absolute value means. So let me just tell what absolute value means. Absolute value is the value specified wherein you can get out the number to be positive without getting any negative numbers. It may be a decimal number or any number, but it should be positive. Just I'm declaring here int main function. I mean the code is starting here, and here I'm printing int result to be 0. Next declaring float statements of three float statements, which are float f1 equals to minus 15, float f2 equals to 20.0, float f3 equals to minus 5.0. So here using the absolute value will give out us the positive number even if we are going to print the negative number. So int I1 equals to minus 7.61. These are all random values according to my requirement. If you want to specify any other numbers according to your requirement, then you may go just specify the numbers according to what you want. So float absolute value result equals to 0. So absolute value of my result must be equal to 0. As I am initializing the float variable, data type, I'm going to print it as 0.0. Float square root float x. So here I'm going to initialize the square root of the specific number also, and I'm just giving here in result equals to GCD equals to 150 and 35. So I'm going to print the Euclid's division lemma of these two numbers 150 and 35. The GCD of 150 and 35 is percentage %d. As we are initializing the int also, we are going to get out the output in the percentage %d, and I'm going to just initialize the result here. So here we have three numbers to be printed, so we are going to initialize three times as three results. So result equals to GCD 1023 and 405, and the GCD of 240 and 83 is percentage %d, and I'm going to get three new lines, and at last I'm specifying the GCD of 83 and 240. I'm specifying 83 at first because 240 is greater than 83, and we are going to divide 83 by 240. So next we are going to test the absolute value function. Absolute value result equals to absolute value of f1. So here f1 is minus 15. So I'm going to test the value of 15.0 first. I mean minus 15.0, and I'm going to just print a statement giving the function that result must be equal to percentage point 2f. So it is going to move two places using the float and just initializing the output. Output here where we are using the absolute value result here. So I'm going to initialize the same here to printf f1 equals to percentage point 2f backslash n and f1. So here I'm giving a input output to initialize that f1 must be 2 points to the right, and then just giving the addressing the f1 value there. So absolute value result equals to absolute value f2 plus absolute value f3. So the total result of absolute value must be equals to absolute value of f2 plus absolute value of f3. And just I'm going to print some statements again here. Absolute printf result equals to percentage to 0.2f backslash n absolute value result. So the statements we are printing here is repeating the same because the absolute value of f2 must plus absolute value of f3 will give us the absolute value result. So here just we are interested into the absolute value of f1, and here in this statement we are adding the two numbers and getting the absolute value result, and then we are next printing the absolute value result equals to absolute value float I1. So I'm going to just initialize a data type into another data type. So absolute value of float must be I1. I'm not just equating it, but just initializing it here in the brackets or parentheses. So the same statement printed here also, as we are interested into the absolute value result, the same is repeating everywhere, and we are going to move two decimal points. So, and then just next we are going to define a division function. So printf percentage point to f and absolute value 6.0, which is the second absolute value, I mean float value. Yes, we are just initializing it randomly. So if you're having different requirement, then you may initialize different numbers and get out your output. Minus 6.0 divided by 4. So here we are going to divide the minus 6.0 divided by 4. And then we are going to take the square root of perfect numbers, I mean perfect squares. For minus 3, we have, minus 3 is not a perfect square. We'll just take 9 and 16, 25, 9, 165. So the lines, I mean the printf statement is same for every line, and we are going to move two decimal points. That is why we are specifying percentage point to f and again returning to 0 and just another and specifying another int main where we have gcd values u and v, and we are going to specify int temp. It is a temporary function, so while v is not equal to 0, temp will be equal to will be divided by v, I mean v will be divided by u. And we are also specifying a function that v must be equal, u must be equal to v, and v must be equal to temp. So the v must be the value equal to the temporary value, and just returning to u function. And we are going to specify another main function, which is float square root float x const float